Lambda expressions are a powerful feature in C# that simplify the syntax of delegates and allow for more concise code. In this lesson, we will explore the concept of lambda expressions, how they relate to delegates, and how to use them effectively in your C# applications. Don't worry if this feels new at first. Now we're on understanding delegates. Before diving into lambda expressions, it's essential to understand what delegates are in C#. A delegate is a type that represents references to methods with a specific parameter list and return type. Delegates are used to define callback methods and can be passed as parameters to other methods. Here is a simple example of a delegate. The samples on screen walk through this step. Take a moment to read through them. In this example, we define a delegate named calculate that takes two integers and returns an integer. We can then create methods that match this delegate signature. Let's move on to using delegates with methods. Let's look at how to use our calculate delegate with a method C. The example on this slide. Pause if you want to study the details. In this example, we created a method add that matches the delegate's signature. We then instantiate the calculate delegate with the add method and call it. Now we're on introducing lambda expressions. Lambda expressions provide a more concise way to represent anonymous methods. Instead of explicitly defining a method, you can define the method inline using the lambda syntax, which consists of the equals operator. The syntax for a lambda expression is as follows. The samples on screen walk through this step. Take a moment to read through them. For instance, the add method can be represented as a lambda expression. I'll let you read the examples on screen rather than reading every line aloud. This single line replaces the entire add method, making the code more compact. Let's move on to using lambda expressions with LINQ. Lambda expressions are commonly used with language integrated query, LINQ, to perform operations on collections. For example, consider a list of integers and a requirement to filter out even numbers. See the example on this slide. Pause if you want to study the details. In this example, we use the where method to filter the list of numbers. The lambda expression n equals n%2 is not equal to 0 checks if a number is odd. This section covers advantages of lambda expressions. Lambda expressions have several advantages. First, conciseness. They reduce the amount of code you write. Also, readability. They make the code easier to read and understand. Finally, flexibility. They can be used in various contexts, such as LINQ queries or event handling. In this lesson, we learned about delegates and how lambda expressions simplify their syntax. We explored how to define and use lambda expressions in place of traditional methods, particularly in the context of LINQ. Understanding these concepts will allow you to write cleaner and more efficient C# code. Alright, your turn. Give this a try. First, create a lambda expression that multiplies two numbers and assign it to a delegate. Also, use a lambda expression to filter a list of strings to find all strings that contain the letter A. Finally, implement a lambda expression that sorts a list of integers in descending order.